what if the most advanced factories of the future were on Earth at all? Imagine production lines floating in orbit, materials forming in perfect microgravity, and entire industries moving beyond the limits of our planet. It may sound like science fiction, but space agencies and private companies are already testing the first steps toward orbital manufacturing. Welcome to Process Protocol, where we break down the systems and technologies shaping the factories of tomorrow. Today, we're exploring one of the most radical ideas in industrial history: factories in orbit. So, why manufacture in space at all? Here on Earth, every single factory faces the same invisible enemy: gravity. Gravity affects how materials cool, how liquids mix, how crystals form, and how precision components behave during production. It introduces imperfections, distortions, and limitations that engineers have learned to work around for centuries. But in orbit, gravity is nearly eliminated, and that changes everything. The real power here lies in microgravity. In this environment, materials behave in ways that are simply impossible on Earth. Liquids don't settle based on density. Tiny particles don't sink. Structures can form without collapsing under their own weight. This unlocks some amazing possibilities, like perfect crystal growth, ultra-pure alloys, flawless optical fibers, and stronger, lighter materials. For example, certain fiber optics produced in microgravity have shown far lower signal loss than those made on the ground. That could mean faster internet infrastructure, more efficient data centers, and better medical imaging systems. And that's just one application. Beyond microgravity, space offers something else that factories on Earth can't easily replicate: a natural, perfect vacuum. On our planet, creating a vacuum requires massive pumps, sealed chambers, constant energy input, and expensive maintenance. But in orbit, the vacuum is free and unlimited. This is ideal for processes that require extreme purity, like semiconductor manufacturing, advanced coatings, and metal 3D printing. In some cases, production yields could increase dramatically compared to Earth-based factories. So, what could we actually make in orbit? It's true that shipping costs still matter, so we won't be building chairs or tables up there. But for high-value, precision materials, orbital factories could be a total game-changer. Key candidates include advanced pharmaceuticals. Protein crystals grown in microgravity can form more perfectly, making it easier to analyze their structure and develop more effective drugs. Another big one is optical fibers, creating ultra-pure fibers for telecommunications, defense, and medical systems. Then there are next-generation semiconductors that require a level of precision that's hard to achieve with gravity in the way. And of course, exotic alloys and 3D printed space structures, where components for satellites and deep space missions are built directly in orbit. Instead of launching entire spacecraft from Earth, future missions could just assemble them in space. Believe it or not, the first orbital factories are already on their way. Several companies are actively developing autonomous orbital production modules, robotic assembly systems, reusable launch platforms, and space-based 3D printers. These factories won't look like the traditional plants we know. They'll be fully automated, AI-controlled, compact, and operated remotely from Earth. Think of a factory floor with no human workers, just robots, algorithms, and the pure environment of microgravity. Now, let's talk about the economics of it all. At first glance, building factories in orbit sounds incredibly expensive, and it is, at least today. But launch costs are falling fast. Reusable rockets from companies like SpaceX and new propulsion systems are driving prices down year after year. As launching things into space becomes cheaper, the whole equation changes. If a material can only be made in space, has an extremely high value, and offers major performance advantages, then orbital manufacturing suddenly becomes economically viable. We've seen this pattern before. Computers were once room-sized and incredibly rare. Solar panels were once too expensive to matter. Electric cars were once considered impractical. Now, they're everywhere. Space manufacturing could very well follow the same curve. Looking further ahead, we might see the rise of the orbital industrial zone. In the not-so-distant future, orbit may host entire industrial ecosystems. Imagine clusters of manufacturing modules, storage stations, robotic assembly hubs, and cargo transfer systems all working together. Products made up there could be sent back down to Earth, delivered to satellites already in orbit, or used for building structures for deep space missions. Instead of just a single orbital factory, we could see entire industrial parks floating high above the planet, a new layer of industry, literally above the world economy. Of course, this journey is not without obstacles. There are still major challenges to overcome. High launch costs are still a factor, along with radiation exposure, extreme temperature swings, and the risk of orbital debris. The logistics are mind-bogglingly complex, but perhaps the biggest challenge is building reliable, fully autonomous production systems. Because once a factory is in orbit, you can't just send a technician up to fix a broken machine. Everything must work perfectly or be able to fix itself. So why does all this matter? Why does it change everything? Orbital manufacturing could redefine entire sectors, from aerospace engineering and telecommunications to medicine and defense systems. The countries and companies that master off-world production may gain massive technological and economic advantages. Just as the Industrial Revolution reshaped nations on Earth, the next great industrial revolution might happen above it. For centuries, our factories have been tied to land, resources, and the constant pull of gravity. But the next generation of manufacturing may leave all of that behind. In orbit, materials behave differently, processes become cleaner, and entirely new products become possible. The question is no longer asterisk if asterisk factories will move into space, but who will build them first? If you want to stay ahead of the technologies shaping the future of industry, subscribe to Process Protocol. Because the next factory revolution might not even be on this planet. Thanks for watching.